Hello, Latin geometry students. Today we're going to talk about our third type of transformation, which is a rotation. Rotation essentially means spin, but we are usually, when we talk about rotation, we're going to be more specific than just say spin. But it is essentially a spin. We're going to take our shape in this blue triangle and we're going to spin it around to its new location. When we talk about a rotation, we're going to describe it using the words clockwise or counterclockwise for our directions, and how many degrees it turns to tell us how far something will rotate. Rotations, just spinning an object from a point. And now the point, this is a little bit tricky, that's essentially where you're holding the paper down that you spin. The point always stays in the same place. It's called the center of rotation. Or we say we rotate about that point. All these are examples of rotations, and in geometry, our rotations will look something like this. So to start with rotations, we'll be using Geogebra, and I'll start with an example. Here, I'm going to do the cow, just to give you an idea how the rotation works. Just like all the other ones, we have a rotation tool, and we're going to select the cow and the center of the graph, and if you do it right, it'll ask you, how many degrees do you want to rotate? Do you want to go clockwise or counterclockwise? That's the direction. All of our rotations will be multiples of 90. So it'll be 90 or 180 or 270 in one of these two directions. So I'm going to go clockwise 90 degrees, and now I have my rotated cow. So in order to perform rotations in geometry, the first thing you have to know is clockwise versus counterclockwise. If you see an old clock, the direction the hands are moving, that is clockwise. If it goes backwards, that's counterclockwise. If you're more of a handy person, clockwise is tightening a screw and counterclockwise is loosening a screw, or clockwise is top to the right and counterclockwise is top to the left. But you have to know these two words, clockwise and counterclockwise, in order to perform rotations. Now, traditionally, to do a rotation, we trace whatever our object is. Here, we're going to take this triangle, and we're going to rotate it so the top is going to go to the left as we go around. So this is counterclockwise. And this person is going to rotate their triangle 90 degrees. And they're just going to spin it 90 degrees. Notice they're using their pencil to hold the center of the graph down. They're performing a rotation about the origin, around 0, 0. In other words, that's the one point that isn't going to move. So here we have a counterclockwise 90-degree rotation. So here, for example, would be kind of an old-fashioned way to do that with the cow. We're going to take this cow and we're going to rotate clockwise 90 degrees. I'm just going to take the whole picture and spin 90 degrees. So now we've gone 90 degrees clockwise. And then next, if we keep going another 90 degrees, this will be 180 degrees down here. And if we keep going again, it'll be 270 degrees. And if you hit 360 degrees going clockwise, we end up right back where we started. Now, keeping track of the coordinates of a point is a little bit tricky. The pattern, which is relatively simple, but there's a lot of different steps to this pattern because there's a lot of different rotations we can do. For example, if we start with this picture, this point here is starting at negative 3, 4. I'm not going to put that in the graph. Instead, I'm going to just show how far it is in each direction from the origin. To get to this point, you go left 3 and up 4. But when we do a rotation, here we're going to go 90 degrees clockwise, and our graph looks like this. Now, our coordinates here, it's right 4, up 3. So our coordinates after 90 degrees are 4, 3. And then if we rotate again to 180, so if we start here, 180 is halfway around a circle, that's 90, 180 is here. Our 180 degree change is now positive 3 and negative 4. Got the typo there. Our clockwise rotation is at 180 degrees, it's positive 3, negative 4. And if we rotate again to finish our rotation here, sorry, I had to adjust that. If I do another one now, this is 270 degrees, and our coordinates have changed again. And at 270 degrees, we have negative 4, negative 3. So the coordinates are changing in kind of a weird way. As we rotate in 90-degree intervals, the numbers, the coordinates of the point keep switching. First the 3 is first, then the 4, so it's 3 and 4, then 4 and 3, then 3 and 4, then 4 and 3. And the signs keep changing. And then if we were to rotate counterclockwise, we'd have this pattern in reverse order. So actually doing the trying to remember all the different ways to change, it can be a little bit tricky. Instead, you probably want to actually do these problems by hand. One of the things that we would normally do is if you had a graph in front of you and it says to rotate 90 degrees clockwise or counterclockwise, is to actually turn your paper and figure out how the points change. But not everybody likes to do it that way, so we're going to talk about doing this in Geogebra. Before we switch over to doing it by on the computer, one of the ones that is worth remembering is 180 degrees. Because if I go 180 degrees one way, what happens to the coordinates is they both simply have switched signs. Negative 3, 4 becomes positive 3, negative 4. If instead we had gone 180 degrees the other direction, say here, if we go counterclockwise, whoops, there we go, we end up in the same spot. So 180 degree rotation ends up simply switching the signs of both the coordinates. Whether you go clockwise or counterclockwise, you end up in the same space. For the 90 degrees and 270, you probably will want to do it using Geogebra or by actually turning your papers. So to perform a rotation in Geogebra, you're going to go to geogebra.org. On the front page, select the Geometry app. Once again, we're going to get a blank screen and we're going to want to add a grid. So you right click, show axes, right click, show the grid and only the major grid lines. And then we're going to graph the same triangle we've been using. You select the polygon tool on the left, click at negative 1, 1, negative 4, 1, negative 4, 3, and then back to where you started. So we've now created our triangle. The tools for the triangle for performing a transformation, over here on the left under the tools, select more. And we're going to scroll all the way down until we find our transformation tools again. And we're going to select rotate around a point. Now our point every time is going to be 0, 0. So we have to have that point on the graph. So since we don't have that point yet, we'll have to put one there. So before we can do this, we're going to go back up to the top of the tools and select the point tool. We have to put a point at 0, 0. It should pop up as point D if you did it the same way as I did. So we have a point that we can use as our center. For every rotation in this class, we'll rotate about this point, 0, 0, called the origin. So once you have that point D, we're going to go over to the tools, slide down to transformations, and we're going to select rotate around point. So if we're going to perform a rotation, let's say we're going to do a 90 degrees clockwise rotation, and we're going to keep track of one of the points. So let's start with the coordinates for point C here. And those coordinates are negative 4, 3. And now we're going to perform the rotation, and we want to keep track of where point C goes. So again, you've selected rotate around point, and we're going to click on our triangle, and then we're going to click on point D. And it's going to ask us where do we want to go. And again, our problem is we're going to go 90 degrees clockwise. So we're going to delete the 45, change it to 90, make it clockwise. And if you haven't started doing this, do this now, because I'm going to ask you where point C ends up before you get to see it. Okay, now if you've done it right, we have our new triangle. This is our 90 degrees clockwise rotation. If we wanted to know the coordinates for C prime, the new point C, we can just look on the graph and count them out. Point C is at 3, 4. So we can get the coordinates of our point simply by doing this in Geogebra. Now I want to go back to the original screen. I'm going to use the undo button until I just have my triangle here with the coordinates negative 4, 3, and we're going to do a couple other problems. We're going to ask you to do a few rotations and ask you to use Geogebra to figure out where they're going to be. If you find some other shortcuts like turning your computers sideways to figure out the coordinates, that sort of trick works, or holding a paper up to the screen and turning the paper, that works as well. So feel free to use that. If you're rotating it with a paper, make sure that you keep the point 0, 0 in the right spot. So your next question is going to be, let's rotate counterclockwise 180 degrees.